All right, number 25, integral of 2x squared plus 5x plus 10 over x cubed plus 2x squared plus 10x dx. We have this big rational function. So which technique is probably favorable when we have a rational function like this? Probably partial fraction decomposition. So can we factor the bottom? Well, I see x is a factor of all of the terms. So let's factor out x first. Oops. Okay. And then we perform the partial fraction decomposition. So let me extend the screen share all the way. Okay. So x squared plus 2x plus 10 is no longer factorable into nice integer numbers. So, or integer factors, I should say. So we keep that as is. And we do the partial fraction decomposition as a over x plus bx plus c over x squared plus 2x plus 10. Remember, when it's a quadratic factor, we have to have bx plus c, that type of thing. And have a linear factor on top, basically. Okay. Multiply both sides by the denominator, you get this first line over here. And we can match coefficients. Remember, that's one of the techniques. Hopefully, you've seen my crash course in partial fraction decomposition videos. I talk about that. So I expand everything out on the right-hand side, and then I group like terms together. So I know that a plus b has to equal to 2. I know that 2a plus c has to equal to 5. And 10a has to be equal to 10. Okay, so let's solve the easy one first, actually, of course. So 10a is equal to 10, as I just said, so a is equal to 1. Okay, we know that a plus b is equal to 2, and we just found that a is 1, so b has to equal to 1. And then 2a plus c has to equal to 5. We know what that a is 1, so c is equal to 3. Okay, in this particular example, it's probably faster to do it like this matching coefficient way, instead of plugging in values of x. You probably have to solve systems of equations if you plug in values of x like that. Versus here, well, we kind of technically did, but it was really simple because we immediately got a is equal to 1. Okay. All right. So do the partial fraction decomposition. The first term is now easy to integrate. That's just ln of absolute value x. Now how about this second term over here? Well, we can complete the square. Okay. So then we get this over here. And now we can make a substitution. U is x plus 1, du is dx then. Okay, now we continue on. By the way, the top would be u plus 2 then. Okay, so that's what I wrote over here. Now this we can separate into two separate integrals. This is like kind of what we just did in the previous problem, or two problems ago. I don't even remember already. Okay, so this first one we can solve with substitution. This one's arctangent. Okay, so that's what happened in this line, and then we got to back substitute u is x plus 1, and then this is our final answer. Look at this beast of a antiderivative, right? I think I said this many times already, but if you punch this into Wolfram alpha, you tell it to integrate this, you might not get exactly this form right down here that I got. But if you tell Wolfram alpha to differentiate this, you actually get back the original integrand. Okay, so that's how we know we did it right. All right. Hopefully this is helpful. This is definitely a more intermediate one, I would say, because first this partial fraction decomposition is a quadratic factor, so that already ups the difficulty a bit usually. And then this integral is not quite obvious to solve, but if you've been following along in this series, we know that complete the square is a very useful technique to be able to solve these integrals. So again, hopefully this is helpful. Please like and subscribe. As always, if you found this helpful or interesting, supports the channel, greatly supports the channel. And hopefully see you in the next video as well. Bye.